Hi everyone. Today's topic is permutation and combination. Today's topic is what? We are talking about permutation and combination. Okay. Guys, permutation combination, it's invariably, awakes, a lot of students. Okay. If people think that it's a difficult topic. Okay. The irony of this particular topic is, it's just about counting the number of ways in which certain event can happen. The irony of this particular topic is just counting, guys. Okay, how many ways we can count it. Okay, how many ways we can count it. Okay, since the count can be extended to large number, we would fall short of fingers. Okay, to count with the hence, certain rules are framed in permutation and combinations. Essentially, those rules are going to help you, in this particular topic. Okay, so it's all about counting, guys. So what are the basic fundamental rules? Okay, so the basic fundamental rules, rule of and rule of and rule of or. Now we'll see turn by turn. Okay, we'll see turn by turn. What is rule of and? If an event can happen in m different ways, event A is happening m different ways, and event B is happening n different ways. Okay, what is A and B will happen? Okay, that is nothing but m into n ways. Okay, m into n ways. How this is going to happen? Let's check this thing. You have, let's say, guys, you have, let's say if I have, three different shirts. I have three shirts, and I have two different trousers. I have two different trousers. So in how many ways, I can, the total number of different ways which I can wear is what, you can say 3 into 2, 6. But how 6 ways will come into the picture? How 6 ways will come into the picture? Let's say I have three shirts. Let's say there are shirt 1, shirt 2, shirt 3. Okay, with shirt 1, I can wear trouser 1 or trouser 2. Okay, with shirt 2, I can wear trouser 1 or trouser 2. Shirt 3, 1 or 2. So how many ways I am doing it? One way, the second way, the third way, the fourth way, the fifth way, the sixth way. Here the numbers are very less, I can do like this. But when the numbers are large, I have 30 shirts and I have 20 trousers, you can't visually write it. Yes or no? That's where you can use, that's where you can use what? The AND method. That's where you can use what? The AND method. Okay, AND method. So you can do this the same scenario like this with the trousers. Trouser 1, trouser 2. With the trouser 1, I can wear shirt 1, shirt 2, shirt 3. Here I can wear shirt 1, shirt 2, the shirt 3. How many ways I am doing? In the one way, the second way, the third way, the fourth way, the fifth way, the sixth way. So total how many ways are there? There are total 6 ways. So guys, it's just all about counting. So the point here is this. So whenever you come across, you need to understand in that particular question, you need AND or OR. Okay, you need AND rule or OR rule. Okay, so once you figure it out this, so AND means always a multiplication. So you can directly, you can say here 3 into 2, you can say there are 6 ways. If you have 30 shirts and 20 trousers, you can say 3 into 2, 6 and 2 zeros, you can say 600 ways. Okay, 600 ways. guys, this not limit to, this rule, it's not limited to just two events. Okay, so in this particular question, I have only two events, no? Yes or no? Are you getting my point? In case one and case two, I can say I have some ties. Okay, if I extended this particular method, like so with this, I have two ties. I have two ties. Then how the logic will continue? There are two events with by wearing a shirt and a trouser, you will have one tie, right? Yes or no? So look at here. So if I extend this method, so let me make some space here. Let me make some space here. So if I have two ties, let's say red color and white color tie, with this I can say the red one and the white one. Again I can say the red one and the white one. Again I can say the red one and the white one. Again I can say the red one and the white one. Are you getting my point? So again you are going to get what, some extra cases. Are you getting my point? Some extra case. So if you figure it out, this 1 2 3 4 5 6 7 8 9 10 11 12 cases. 12 cases. So that is nothing but, so 3 into so shirt and trouser and a tie, so that is nothing but 3 into 2 into 2. That will give you 3 to the 6, 6 to the what, guys? 12. Okay, 6 3 is a what, guys? 12. So the point here is this. Okay, if you look at in the above this particular, if you look at here, it is obvious because it is shirt trouser tie. We regularly mix and match. What about the same question, like how many three digit number can using 1 2 3 4 5, each digit being used only once? Yeah, this is a regular case. But someone they are going to ask you how many three digit, how many, okay, how many three digit numbers can one form using 1 2 3 4 and 5. Each digit is using, let's say, each digit used only once, used only once, used only once. Okay, used only once. Yes, well, this question is exactly same as the above. Just as we have a fixed place for wearing shirt, trouser and tie, in this situation what we have? We have three digits. What we have? We have three digits. Yes or no? Okay, so one is a unit place, one is hundreds place, one is what, thousand place. So which number where I can write, that's my logic. Okay, so now instead of two trousers, three shirts and two ties, we have the digits called what? Yeah, 1 2 3 4 and 5. These are the digits. Okay, the only difference that any of the digits can be any place. Unlike the fact that you cannot wear a shirt a place of a trouser. Obvious, no? Yeah, you have to wear on the top, you have to wear your shirt, not trouser. Starting with the thousand position, it can be filled, there are 5 ways, no? Yes or no? Because 1 2 3 4 5, any of the number can come and sit here, no? So I can say this is the 5 ways. Yes or no? Are you getting my point? So when this is a 5 ways, okay, in each case, there are 5 ways. Once the digit out of 5 digits has been used, cannot be used once again. This is not number 5. This is the number of ways. Okay, let's say the 3 is fixed here. You cannot use 3 again here. Yes or no? You cannot use 3 again here. Are you getting my point? Okay. So thus, each of these above five ways, there are further n ways. That's obvious, no? If there are these five ways, there are further what? Four ways. In for which the hundreds position, you can place how many ways, guys? Four ways. Okay, out of these four, one number is fixed, any of the number. Okay, any of the number, so in which the 10th digit can be filled, any of the remaining four digits that could be filled in tens position. Those we can say 5 into 4, 5 into 4, you can say there are 20 different ways, okay, which the 110th digit can be filled. Okay, there are 110th digit can be filled, but the question is not yet end. Okay, the question is not at end here. Okay, so you need to understand there are further ways. Okay, there are further ways. Let's try to figure out this particular thing, being we are very initial way. We'll try to understand everything, how actually the permutation combination will come. Let's say if I put the first position with one, there are two places are vacant. Okay, what are the places vacant? One here, two here. Because I'm talking about only with the 1,100 positions. You can write what? 1 3. You can write what? 1 4. You can write what, guys? 1 5. Okay, let's talk about 2. If I fix the 100th position with 2, you can write what? Yeah, you can write what? 2 1. You can write what? 2 3. 2 4. Because you cannot use 2 2 because you have to use only once. 2 5. Okay, let me fix this with 3. Okay, then you can write what? 3 1. Okay, 3 2. Okay, 3 4. What? 3 5. If you fix with 4, okay, 4 1, 4 2, 4 3, 4 5. You can fix this with 5. Just I'm telling how the idea actually develops. 5 1. Okay, 5 2, 5 3, 5 4. Total how many ways are there? Four ways, four ways, four ways, four ways. 4 5s are what? 20. That's what I have told 5 4s are how much, guys? 20. Yes or no? This is how you need to develop your answer. But the point is this: further in each these 20 ways, two digits out of this available five digits would have been used, cannot be used once again in filling the numbers in the units place. Okay, already two positions is fixed. You cannot use again whatever digits you have used, you cannot use the other digit. Yes or no? So there are 20 ways, and further there are 3 ways. Okay, that is nothing but 20 into 3, that will give you what? 60 ways. So instead of all this particular stuff, instead of all this particular stuff, okay, what you need to understand is this. Okay, what you need to understand is this. Okay, using the AND rule, the 100 position can be filled. There are 3 digit number. 100 position will be filled with what? 5 ways. Okay, 5 ways. Okay, having filled the 100 position, the 10th position can be filled with how many ways, guys? 4 ways. 4 ways. And having done this, okay, the unit position can be filled in how many ways, guys? 3 ways. 3 ways. Since we have to fill the 100 position and, okay, 100 positions and 10th position and unit position. The total end means what? It's a multiplication. End means what, guys? It's a multiplication. So that will give you 5 into 4 into 3. So 5 4s are 20. 20 into 3 is what, guys? 16 ways. 20 into 3 is what, guys? 16 ways. This is all about rule of AND. Okay, this is all about what, guys? Rule of AND. Are you getting my point? Okay, this, guys, it's all about counting. Just it's all about counting. Okay, counting. Okay, let's we'll try to solve few questions in let's say we'll try to solve Now we'll talk about rule of R. Now we'll talk try to talk about, guys, we'll do one question, then we'll go for rule of R. Okay, please write down example. Please write down an example. Okay. uh, Let me draw a diagram. Let's, this is A, this is B. A to B, there are three ways to reach A to B. If there is city A, there is city B, there are three ways I can reach the city B. From B to C, there is another C. From B to C, there are again four ways. Let's say, let me name it as P. Okay, let me draw clearly. Yeah, so P, let's say Q, R, S. Okay, there are three ways to travel from A to B and four ways to travel from B to C. They'll ask you questions. Question number one: in how many different ways can one travel from A to C? This is the first question. We'll try to solve this. We'll do one by one. Okay, guys. The point is this: A to B, how many ways are there? A to B, how many ways are there? Three ways. B to C, how many ways are there? Four ways. Okay. Since one has to choose a way from A to B and B to C. Okay, the total number of ways must be what, guys? And A to B or B to C is not the case. A to B and B to C, which means there are three ways and there are four ways. 3/4 of what, guys? 12 ways. Okay, 3/4 of what, guys? 12 ways. Okay, 3/4 of what? 12 ways. How? It's very simple. Root 1 with P. Okay, Q, R, yes. Root 2 again, P, Q, R, and S. Root 3, P, Q, R, yes. 4, 4, 4. Okay, 4 plus 4 plus 4 is what? 4 plus R, 4 R, 4. Okay, so that means here 4 plus 4 plus 4 will come here. That will give you 12. That will give you what? 12. This is one way. This is the other way. This is the other way. Okay, this is the other way. This is how you can reach A to B and B to C. Okay, A to B and B to C. It's a very simple question. Okay, very simple question. I hope everybody got here. Okay, sometimes he'll ask you, they'll ask you like this. Let's talk about question number 2. Let's talk about the question number 2. In how many ways, different ways we can travel A to C? Okay, A to C and come back to come back to A. Okay, come back to A. Guys, that is nothing but 3 into 4 from here. Now look at here. Now you are going back here. Okay, now B to C, 4 and 4 into 3. Okay, so that is nothing but 4 3 is 12. So 12 into 12, that will give you what? 144 ways. Okay, 144 ways. Okay, the total number of ways will be what, guys? 144 ways. Logically, for each of the about 12 ways of going A to C, there are further 12 ways of returning from C to A. That's where the total number of ways, the round the trip will be what? 12 into 12, that will give you 144. Okay, you cannot list out 144 here. Okay, so that's why if you want, you can take your time and you can list out the 144 ways anyway. Okay, but it will take some time to calculate it. So guys, please understand, either you want and, here you are using and, yes, I am using, because A to B and B to C and B to C and B to A. Okay, so that's why 3 into 4, so 4 into 3, that will give you what, guys? 144 ways. Okay, that will give you what? 144 ways. I hope you understand these two particular questions. Okay, now we'll talk about rule of, okay, a rule of R. What is the rule of R? Okay, what is the rule of R? Now, when to use actually rule of R? Okay, the rule of R is used in cases where there are two or more distinct ways in which the event can happen. Okay, and each of the two cases needed to be handled independently. When there are independent cases, we have to use R cases. So if event A can happen in m ways, m different ways, okay, and event B not, and event B happens in different ways, okay, in different ways, okay, event A or B, he's talking about the conjunction is what here are. In the previous case, the conjunction is what, and. So the total ways must be m plus n ways. Okay, 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 m plus n ways. We'll try to solve with one particular question. Okay, we'll try to solve with one particular question. Okay, how many natural numbers can be used? How many natural numbers can be used? How many natural numbers can be formed using any or all the digits, any or all the digits from digit, what are the digits? 1, 2, 3, 4. Okay, so each digit being used maximum one time. Okay, maximum one time. He's talking about what? Natural numbers. So natural numbers start with what? 1. Okay, the only difference between this question and the example I have explained earlier. Okay, so the point here is what? Here I can say that there are 4 numbers. So he's talking about natural numbers. So I can say there are single digit numbers. Yes or no? Single digit numbers. And what? 2 digit numbers. Okay, and what? 2 digit numbers. Okay, and you can get what? Single digit numbers you can get. Okay, 2 digit numbers you can get. Okay, and what you are going to get? 3 digit numbers. Yes or no? Okay, 3 digit, and 4 digit, the numbers also you are going to get. But how many single digits number can be formed? You have to use only one number, so 4. Okay, 4. Yes or no? Are you getting my point? 4. R. If you wanted 2 digits, yes or no? So total numbers are available 4. Okay, one number is already used, so this could be 4 3s are 12. If you want 3 digit numbers, so 4, 3 and 2, you should be fast here, yes or no? 4 3s are 12, 12 2s are 24. Okay, 24. Are you getting my point? If you want a 4 digit number, same, 4 3 2 1, so that will give you also 4 digit. So here the point is this, by using these digits, okay, now we need to add or multiply among, this is a point, So actually what you want, a single digit, or 2 digit, okay, or 3 digit, okay. The conjunction is what here, guys? Or the 4 digit, okay, the 4 digit. So that's going to be 4 plus 12 plus 24 plus 24. Okay, so if you add all these, 24 plus 24, 48, 48 plus this 12, 48 plus 12, 60. So that will give you 64. So you need to add 4 plus 12 plus 24 plus 24. That will give you total 64 ways are there. By using 1, 2, 3, 4, you need to frame how many natural numbers? Single digit, or 2 digit, or 3 digit, or 4 digit. So the conjunction here is what? R. The conjunction here is what, guys? R. Okay, the conjunction here is what? R. Guys, for permutation combination, definitely you should know these two rules for sure. What are the rules, guys? The rule of and the rule of R. Okay, the rule of and the rule of R. So if you know these two rules, you can solve any question, without using a formula. Okay, you can solve any question without using a formula. Let's talk about our actual concept of permutation and combination. Let's talk about the permutation first. What do you mean by permutation? Permutation is nothing but arrangement. Okay, permutation is nothing but what, guys? Arrangement. Okay, arrangement. Okay, permutations are nothing but what? Arrangements. Generally, arrangements are characterized by specific way in which objects are arranged. Okay, specific way, the objects are arranged. The word arrange, suggests a specific order. Okay, this suggests what? Order. Okay, this suggests what? An order. You know, among the objects being arranged. Okay, among the objects being arranged. Example we'll take, we'll take one example. There is a fork and there is a knife. Okay, there is a knife. There is a spoon on a table. In how many ways these are going to be arranged? Let's say, spoon, fork, knife. Yes or no? This is one way. Or you can say spoon, knife, fork. You can say fork, fork, spoon, or you can say knife. Let me arrange like this. Knife, spoon, fork. Knife, okay, knife, fork, and spoon. Okay. Each of the above, guys, this is a one way, second way, the third way, the fourth way. If you look at each of these, different, they are different because of what order? Placing the three different objects, yes or no? So when we say order, we refer, the relative placement of the objects among themselves. Okay, among themselves. So each of one way, way 2, and way 3 are different because each has different objects in middle. Yes or no? Each have, look at here. Here fork is there, here knife is there, here what? The spoon is there. Okay, But if you look at 1 and 4, I can say fork will come in the middle. Yes or no? Same objects in the middle. Yet they are different ways because in way one the spoon is to be left of the fork, and in way for the knife to be the left of fork. That's why they are different. Okay, you can write, you first, what I've placed here: spoon, spoon, knife, knife. You can place fork here: fork, knife, and spoon. Fork, spoon, and knife. Okay, you can do like this also. So what I make you understand here is, what do you mean by arrangement? Okay, and how the important of order, arranging the objects, those, placing the objects in specific position. Okay, arrangement, order, and next you need to concentrate what? Position. Okay, position. There are all the possible ways arranging the three objects. It should be easily possible for we are upcoming with more ways, and those, we are not the only way. So what is the total number of possible ways? In the previous question, 1 2 3, this is the 5 and this is the 6. I can write like this. Let's say fork, knife, spoon is there. I can say there is a plate. There is, if you put all the cooking room, the list of here, there are how many ways are there. So for this, what are the ways actually? 3 into 2 into 1, that will give you 3 to the 6, because there are 3 ways. So this position 3 ways, this position 2 ways, this position 1 way. So you can say there are 6 ways. Okay, so the point is here, what we are doing here, here we have 3 positions and 3 objects. The first position can be filled with 3 ways. Okay, with any of the fork or spoon or the knife occupying it. Having filled this, for each of the 3 ways, the second position can be further filled in 2 ways. Either 2 of the remaining objects, whatever may be filled in the first position, the remaining could be, will take the second position. Now, having filled this, the third position can be in only one way, with the remaining object. So since we can say that, 3 into 2 into 1, that will give you 6 ways. The point here is this. There's the arrangement of, objects in position. Please, remember arrangement of the objects in position, order in position. Okay, primarily use the same funda as what the rule of and only, yes or no? What we are using? The rule of and. Okay, the rule of and. Okay, the point here is this. Guys, if you look at here, in this case, we had to arrange 3 objects in 3 places. What if the number of objects are more than the number of positions? Are you getting my point? There are 3 objects, 3 positions, that's fine. Okay, let's say we have used one thing. Let's say we have already solved one questions, like what, there are 3-digit number, by you can using digits of what, 1 2 3 4 5 and 5, and each digit used once. It is obvious that all, not all the objects can be arranged for the position 1. Okay, the first position can be filled in 5 ways. Each of the 5 ways, the second position can be further 4 ways. Yes or no? So here, n number of objects and n number of vacant positions. Does the situation will always occur the same? No. In the previous question, we have seen what? I want a 3-digit number by using the digits 1 2 3 4 5. Yeah, then first position there are 5 ways. The second position I can say there are 3 ways. Yes or no? And 4 ways, 5 4 3 2, 5 4 3. Okay, so then 5 4 3, so 5 into 4 into 3. Okay, 5 into 4 into 3 is what, guys? 60 ways. So the point is this, the reasoning, remains same. Okay, the reasoning what here? The remains same. Okay, so while we are discussing, the permutation, which means arrangement, that is nothing but I am arranging n articles. Okay, there are n articles. Okay, so we can say defining, we are going to define NPR. As we seen earlier, the number of ways arranging three objects out of three objects. Three objects out of three objects. That will give you what? 3 into 2 into 1. The number of ways we are arranging, three objects out of five objects. Then what is the situation? What we are writing? 5 into 4 into 3. Yes or no? The same logic, if I say there are, let me erase this again, you will get confused. Yeah, confusion will come. I want to arrange 3 out of 11. What I'm going to write? Yeah, 11 into 9 into, 10 into 9. Are you getting my point? Let's say if I want to arrange, 6 objects, this is object, this is the total number. Okay, this is the object, this is a total number of ways, total objects. But I'm arranging only these objects, out of, let's say 9 objects. It's going to be the first position 9 ways, the second position 8 ways, the next 7 ways, next 6 ways, next what? 5 ways. Okay, and the next what? 4 ways. 1 2 3, yes, 4. So this is how you're going to get. So to generalize this particular funda, okay guys, we are not coming how formula is developed, we are doing it how actually the formula is developed, how actually NPR will come into the picture. So if you want to generalize this this particular thing, okay, the number of ways of arranging R objects in a row out of n distinct objects, that would be what? N into n minus 1 into n minus 2 into and so on. Okay, these are what, guys? These are what? Total of n factors. Sorry, total of what? R factors. Because NPR, no, R factors. Okay, R factors. Those, you can explain, this expression is defined as what? NPR. Okay, so this expression is defined as what, guys? NPR. To calculate the value of NPR, one would necessarily do what they are going to do? N into n minus 1 into n minus 2, okay, and so on. But then this is not the ideal way of write a formula, because we need to write the text, the total for R factors, no? Yes or no? So to come up with the proper formula, NPR, look at the following working. Okay, we'll try to write it. Okay, it can take help that the product of n into n minus 1 into n minus 2 so on to what? N factorial. The product of the remaining one. The creative way of writing is this. Let me finish it out this. So actually, if you want to write NPR is equals to n factorial by n minus r factorial. Okay, so if you want to write, guys, if you want to write, let me erase this. So NPR is equals to what? N factorial by n minus r factorial, because, yeah. So if you want 11P3, how you are going to write? So generally, actually you need to write what? 11 into 10 into 9 into so on up to 1 and divided by n minus r. So you have to write till where? N minus r is nothing but what? N minus r is nothing but what, guys? So this could, you have to write 11 factorial. Here you need to write 11 minus 3 factorial. That means 8 factorial, which means 8 into Okay, 7 into 6 into and so on. So let me write 8 also here and so on till what one. When you are doing this, definitely this is going to be cancelled, no? Yes or no? Definitely this is going to be cancelled. So unless otherwise you are going to end with 11 into 10 into 9 only, no? Yes or no? 11 into 10 into what? 9. Are you getting my point? Okay. A few permutation that should be known as, directly without using a formula. NP1, okay, N, okay. Since we have, to just choose one object, any, o- it could be any of the given N objects, okay. Let's say sometimes they'll give NPN, which means N factorial, okay. So the first position can be filled in n ways. The second position can be filled is what? N minus 1, n minus 2, so until where n, which means what? N into n minus 1 into n minus 2, so on up to n, which means what? N factorial only, no? Yes or no? So these, to sum up the number of ways of arranging R objects in a row out of n distinct factors. So let me summarize this. So if I want to arrange R objects out of n distinct objects, so that is nothing but NPR. NPR will give you what? N factorial by n minus R factorial. Okay, so if you want to calculate this simply, you can write like this. How? N into n minus 1 into n minus 2, so on up to this is what? R factors. Okay, this is what, guys? R factors. Okay, R factors. Okay. So we'll start with arranging the digits. Okay, we'll start with what? Arranging the digits. How we are going to arrange the digits. Okay, arranging the digits means what? Forming numbers. As seen, we have seen above. These digits you can use by using these many numbers. Is the same as arranging the digits of the funda, that we use the rule of and. However, while forming the numbers, there can be many conditions like, forming an even number, forming greater than, a given number, forming a number, that are divisible by a given number, etc. We'll see all the questions, which are different cases, we'll see. Okay, we'll see all the way of how we are going to solve this. Let's try to write down a question. Let's try to write down a question using digits. Using digits 1, 2, 3, 4. How many? How many 3-digit numbers can be formed? Can be formed if repetition of the digits is not allowed. Okay. Okay. Yeah. And you can say this question is very easy since we have already discussed this. To do a pay attention, I have already explained you this particular question. Okay. Okay. The number of ways in which place one, what do you want, guys? You want a 3-digit number. You want a 3-digit number. Okay, the number of ways in the first place and the second place and the third place can be filled with there are how many ways I can fill this? There are how many numbers? 4 numbers, 4 ways, and this number would be 3 ways, and this number could be what, guys? 2 ways. So end means what? 4 with 3 is a 12, 12 2 is a 24 ways. Okay, 24 ways. You can say this as what? 4p3. Out of 4, you are arranging what? 3. You are not selecting. You have to arrange them. Okay. In notation, if you write, 4p3, you are going to end. That is nothing but 4 into 3 into 2. Okay. 4 factorial by 4 minus 3 factorial. That will give you 1 factorial. So that will give you your answer. Yes or no? Okay, that will give your answer. So how many ways, guys? 24 ways. Okay, so 24 ways. Okay, 4 factorial is nothing but 24 again. Okay, now let's go to the next question. Please write down. Using the digits, using the digits. Okay, using the digits 1, 2, 3, 4. How many 3 digits numbers can be formed if a repetition of the digits is allowed? Yes. Okay, when the repetition is allowed, then how I am going to do this? Okay, okay, when the repetition is allowed, how I am going to this? You know, guys, what are the digits you can use? 1, 2, 3, and 4. And you want which number? A 3-digit number. Okay, since a digit can be reused, each of the 3 positions can be filled with 4 ways. No, yes, here I can put out of these 4 numbers, so I can write this is 4 ways. Of course, this is also 4 ways. Of course, this is also 4 ways. Yes or no? So end is the conjunction here. 4 4, that is nothing but 4 cube. 4 cube is nothing but what, guys? 64 ways. 64 ways. In this you need to understand one point. We cannot use NPR here. Okay, when the repetitioners are allowed, NPR is not going to be possible. So that's why uh, adapt to this method. This will help you a lot. Okay, this will help you a lot. Okay, next question. Using digits 1 2 3 4 5 6 7. Using digits 1 2 3 4 5 6 7. How many? How many? So let me take the digits 1 2 3 4 5 6 7. Okay, how many 5-digit even numbers can be formed? 5-digit even numbers can be formed. 5-digit even numbers can be formed. Okay, even numbers can be formed without repeating any digits. Okay, without repeating any digit. Okay, guys, in this particular question, you can use these numbers, but you need what? You need only even number. Yes or no? You need only even number. When a number want to be even, what is the condition? Yes, it is a 5-digit number. The last digit should be even. Then only then only that number we can call it as what even number. So if you want, this number should be even whenever there is a condition is given. Okay, whenever you come across a condition, okay, then you have to decide which is the priority. Okay, then you have to decide which position is the priority. Yes, of course this position is a priority. Yes or no? Okay, so I want this number should be even. So how many ways I can fill this? Either this is in 2 or 4 or 6. Then only I can say this particular number is even. So I can say this is 3 ways I can fill this. Yes or no? This is how many ways I can do this? 3 ways I can do this. Okay, but 2 4 6, because I can use only one, so any of the number is going to sit here. Yes or no? So out of this, let's say 2 is filled here. So remaining position, how many ways? 5 ways, no? Because one number is fixed here. This is what? 4 ways, no? This is what? Sorry. There are how many numbers? 1 2 3 4 5 6. No, sorry. This is what? 6 ways. Let me correct this. Yeah. So this is what? 6 ways. This is 5 ways. This is 4 ways. And this is what? 2 ways. Okay, because here you need to understand the last digit must be what? Even. When the last digit is even, okay, when the last digit is even, so definitely this is going to be what? Yeah, 2 into 4 into 5 into 6 into 3. Okay, 6 5s are 30. 30 into 4. Okay, 6 5s are 30. Okay, 6 5s are 30. Okay, so let me multiply this 8. Okay, 8 and 30. So 8 and 30. So 8 3 is how much, guys? 24. Okay, 8 3 is how much, guys? 24. Okay, so 22 40, no? Yes or no? Guys, the unit digit can be filled with what? 2, 4 or 5? It's a 5-digit number or 4-digit number, guys? Yeah, of course it's a 5-digit number, no? By using the digits, I want 5-digit even number. Yeah, without using any digit repeatedly. Okay. So guys, having the unit digit is filled with 3 ways. 4 more places have to be filled. We have 6 different digits. So that can be 6 into 5 into 4 into, okay, 4 into 3. Okay, 6, 5. Yeah, I'm writing this as 3 ways. So that's why, yeah, so this is 3. So this is not 24. This is what? 360. Because, that's why I'm wondering how I'm getting 240. I need to get 360. Yeah, so 360 into 3, that will give you. So guys, multiply. This is 12. 12 5s are, yeah, 4 3s are 12. 12 5s are 60. 6 6 are, 360. So 360 into 3. So if you multiply this, you are going to get 1080 ways. Okay, 1080 ways. Are you getting my point? 1080 ways. Very simple logic, guys. Let me explain this question one more time. You want a even number. You want a even number, and it should be a 5-digit number. What are the digits available? 1, 2, 3, 4, 5, 6, and 7. Okay, what are the even numbers? 2, 4, 6. If a number want to be even, the unit digit must be even. So what are the position? What are the numbers will come here? 2, 4, 6. You can say 3 ways it's going to fill this. Having filled any one of the number, because I cannot fill all the 3. If you want to do it, you can do like this. I can fix 2 there. I can fix 4 here. I can fix here 6. When this is one way, let me clear you one thing. When this is one way, this is going to be what? Yeah, 2 is fixed. So remaining, so 6 5 4 3. Here also 6 5 4 3. 6 5 4 3. Okay, 6 5s are 30. 30 into 12. That's it, right? 6 5s are 30. 4 3s are 12. 12 3s are 360. So this is 360. This is also 360. This is also 360. 360 R, 360 R here. So 360 into 3. That will give you what? 1080. That's what I am doing here. No. So this is 6 ways, 5 ways, 4 ways, 3 ways. So instead of adding this, I am multiplying here. So 3 into 4 into 5 into 6 into 3, that will give you 1080. Okay, that will give you what, guys? 1080. Okay, 1080. So that's how you can say, you can fill that particular, you can write that as what? 1080 ways. Okay, 1080 ways. Okay. Why can't we do this? Is what? Without repetition. When the repetitions are allowed, then how? What is the answer? Based on the repetitions are allowed, you need to think like this: 1 2 3 4 5. I want a 5-digit number. How many digits available? 7 digits. So any place can take 7 values. No. So which means 7 into 7 into 7 into 7, that will give you 7 power 5. So what is 7 power 5? If you remember, you can say 7 power 5 as 7203. Okay, how? 343 into 49, because 7 cube is 343, 7 7 is 49. So if you use 343 into 49, you are going to get what? 7203. Okay, 7203. This is how you can end your answer. Okay, you can end your answer. Whenever it is going smoothly, if the question is like this, how you are going to answer the things. Okay, so please write down. Using digits 0, 1, 2, 3, 4, and 5. How many 4 digit, how many 4 digit numbers can be formed, using each digit only once, yeah. These are the digits. And which digit you want? You want a 4 digit number. Yes, this is a 4 digit number. Okay. But only one point here. Which position you need to fix first? That is the priority here. You know, so the 0 does not appear in the leading position. Let's say if this is a position, if I am writing 0 here, it's going to be a 3 digit number. So 0 will come here, not at all. 0 will not come here. So that's it. Once you understand this particular point, okay, so we have to, you can fix this, units position, thousand position, 100 position, okay, 100 position, yeah. So you can say the point is this, friends. Yeah, the point is this. So can I say, so 0 will come here? No. So 0, 1, 2, 3, 4 and 5. So can I say this position can be right with 5s? Yes or no? Yes or no? So any of these numbers, out of these numbers, one number is fixed here. Let's say 3 is fixed here. What about this position? Yes. Now 0 is available to this position? Of course, yes. Yes or no? You can write, 3045. It's a 4 digit number. Of course, yes. So when 0 is available here, now, in this particular set, 0, 1, 2, 4 and 5 will come. Yes or no? Because I assume 3 is fixed here. Okay. So now how many ways again? Again, you can say there are 5 ways. Okay, again you can say there are 5 ways. Out of this, let's say 0 only fixed. For the next set, how many numbers available, ma? 4 numbers. So you can say how many ways? 4 ways. Let's say 4 is fixed here. Let's say there are, next set is what? 1 to 5. So how many numbers available here? 3 ways. Okay, how many numbers available here? 3 ways. So you can say the total number of ways, 5 into 5 into 4 into 3. 5 5 is a 25, 25 4 is a 100, 100 into 3 is what, guys? 300 ways. Okay, by using 0, 1, 2, 3, 4, 5, you can write 4 digit numbers. 300 you can write. Okay, 300 you can write it. Okay, is this clear, everybody? Yeah. So if I ask you when the repetitions are allowed, then yeah, so the point is very simple. When the repetitions are allowed, 1, 2, 3, 4, your concentration must be this only. Here 0 will come, it's going to happen? No. If the repetitions are allowed also, 0 will not come here, because when 0 is coming here, it's going to be 3 digit number. So this is only 5 ways. Remaining all are 6 ways. So that is nothing but 6 cube into 5. 6 cube is what? 216 into 5. Okay, 5 6 are 33, 5 8. So 5 2 are 10. So you can say 1080 ways when the repetitions are allowed in this particular example. Okay, repetitions are allowed in this particular example. Okay, in this particular example. Is this clear, everybody? Yes. Okay, next question. Okay, please write down the next question. Okay, yeah. Using digits. Okay, using digits 2 3, using digits 2 3 4 5 6. Okay, how many 4 digit numbers can be formed such that they are divisible by 3? They are divisible by 3. They are divisible by 3. Repetition of digits is not allowed. Okay, repetition of digits is what? Not allowed. So, what is divisibility rule of 3? The divisibility rule of 3 says that, the sum of the digits should be divisible by 3. Also, we have to use any 4 out of the 5 given digits. Since a 4-digit number, because I want a 4-digit number. So first let check a number formed by 4 digits, it's going to divisible with 3. We'll take turn by turn. Let's say if the digits are, if we use 2, 3, 4 and 5. Okay, because I'm not using 6 for a moment. The sum of the digits is what? 5 plus 4, 9, 9 plus 14 I'm going to get here. Yes or no? So sum of the digits, 14 is going to divide with 3? No. No, so it's not going to divide with 3. So this is one of the case. Okay, if I take, 2, 3, 4 and 6. 10, 10 plus 3. 13, 13 plus 2. Okay, the sum of the digits is what, guys? 15. So this is going to divisible with 3? Yes. Okay, this is going to divisible with 3? Yes, keep aside. Let me use, if I use the digits 2, 3, okay, 2, 3, 5 and 6. Okay, so 2, 3, 5 and 6. 11, 11 plus 3. 14, 14 plus 2. 16 is going to divide with 3? No, which is not divisible. If I use the digits of 2, 4, 5 and 6. 15, 17. 17 is dividing with 3? No. Okay, if we use the digits 3, 4, 5, 6. 3, 4, 5, 6. So 10, 15, 18. 18 is going to divide with 3? Yes. Yes. Okay. So these are the digits, only, there are there are sets, only 2 sets which are divisible with what, guys? 3. Okay. Okay. What are the sets actually? Yeah, 2, 3, 4 and 6. The other is what? 3, 4, 5, 6. Okay, 3, 4, 5, 6. Okay, 3, 4, 5, 6. So with each of these sets, we can form 4p4. No, out of 4 I can use 4. So that is nothing but a 4 factorial. 4 factorial means what? 4 into 3 into 2 into 1. So that will give you 24 numbers. That will give you what? 24 numbers. Okay, and one set there are 24 numbers. So the other set also 24 numbers. So I can use this or this, which means 24 plus 24, that will give you 48 numbers. That will give you what, guys? 48 numbers divisible by 3 can be formed by using the digits 2, 3, 4, 5, 6. So total numbers are what, guys? 48. Okay, 48 numbers. Okay, let's go to the next question. Next question. Using digits, using digits, using digits 1, 2, 3, 4, 5, 6 and 7. Using digits 1, 2, 3, 4, 5, 6 and 7. 7. Okay. Find the number of distinct 4-digit numbers. Without repetition, guys, I have to use only one time. Find the number of distinct 4-digit numbers. Okay, 4-digit numbers that can be formed for each of the following conditions. Let me write the condition. Condition number 1. Greater than 3000. You need to find greater than 3000 numbers. Okay, by using these digits. Question number 2, even numbers. Okay, question number 3, even numbers. Okay, even numbers greater than 3000. Even numbers greater than 3000. Okay, you know we'll try to solve 1, 2 and 3. What are the digits we can use? Yeah, I can use 1, 2, 3, 4, 5, 6 and 7. Okay, I can use 1, 2, 3, 4, 5, 6 and 7. Okay, so without repetition. So let's talk about greater than 3000. You want you want 4-digit number, right? So take four positions, 1, 2, 3 and 4. Okay. Okay, so how this is going to be? Guys, whenever someone like more than 3000, they'll take only 4, 5, 6, 7 ways. Okay, so because whenever this is a condition, you have to start with this particular number. Okay, because this number is important. No, so this number can be filled with how many ways? Yeah, people 90% they'll think that 4, 5, 6 and 7. No, there is 3 will also come. 3000, 3245 is also more than 3000, greater than 3000. 3000, 200 and 67. It's also, so I can fill this particular position in how many ways? 1, 2, 3, 4, 5 ways. Yes or no? Okay, this particular number I can fill with how many ways, guys? 5 ways I can fill this. Yes or no? So once out of these numbers, one number is fixed. Let's say this is fixed here. So remaining, whenever this is the condition, you have problem with this particular position only. When this position is fixed, you can write further. Okay, you can write further. So that is nothing but you can say this is what 5 ways. So out of these 7 numbers, one number is fixed. So next position must be 6 ways. Next position must be 5 ways. Next position must be 4 ways. So that is nothing but you can say your answer is 5 into 4 into, sorry, 6 into 5 into 4. Okay, 5 4s are 20. 20 into 6, 120. Sorry, 5 4s are 20. 20 into 6, yeah, 120. So 120 into 5, so 12 5s are, okay, 12 5s are what, guys? 600. Yes, by using these digits you can form a 4-digit number which is more than okay 3000. How many ways, how many numbers you can write it? Yeah, you can write it how many numbers? 600 numbers you can write. What is the second question? I want even number. Even number, pretty easy thing. Okay, already we have solved this. When you want an even number, 1 2 3 4, let me clear some space for you. Yeah, guys, if you want an even number, when you want an even number, what is the condition? Yeah, if you want an even number, definitely 1 2 3 4, this place is important. No, this should be even. 2 or 4 or 6, how many ways? 3 ways. One number is fixed here, so this is 6 ways. So this is 5 ways. So this is what, guys? 4 ways. So that is nothing but 4 into 5 into 6 into 3. So if you calculate this, you are going to get it. Okay, 4 5 is a 20, 20 into 6, 120, 120, 12 3 is a 36. You can say there are 360 ways, which means 360 numbers are there. Okay, 360 numbers are, which are what? Yeah. Okay, so in the previous question, in the previous question and in this question, okay, so you can say you can use with the formula also, that you can do after, you can use the formula and you can do it. Okay, but I don't prefer with formula. I always simply I can do it. No. Okay, so think the logic and you can get your answer. Okay, so we'll go to figure it out the next one. What is the next one? Yeah, even number greater than 3000. Okay, even number greater than 3000. You know, the number must be even. Okay, and that should be greater than 3000. Yes, I have how many conditions? I have two conditions. Guys, whenever you have two conditions, you know, you should be very clear. You know, some people will write like this. Yeah, so I want a even number. So 2, 4, 6. I can say this is three ways. Okay, so I want more than 3000. So you can write this as 3, 4, 5, 6, and 7. They can write this is five ways. So two numbers are fixed out of five numbers. So they can write this is also five ways. This is four ways. So 25 400. They end up with answer called 300 ways. No, that's a wrong answer. Why this is wrong? Look at here. 1, 2, 3, 4. This number must be even. So 2, 4, 6. Yes or no? If I want fill this number with 2, 4, 6. Okay, 2, 4, and 6. So can I say, let's say this is fixed with 2. I don't have any problem. If I fixed this with 2, yeah, that numbers are ending with 2, you can get it. Okay, but if I fixed this with 4, 4 will not come here, no. 3, 4, 5, 6, and 7. So 4 will not come here. When 4 is not coming here, this is only 3 ways, right? Sorry, 4 ways, right? Are you getting my point? Then how the situation will come? Okay, so whenever you come across, there are two conditions in the question. Okay, whenever there are two conditions in the question, break the condition. Okay, I want an even number, right? So when I want an even number, okay, what are the digits available, guys? 1, 2, okay, what are the digits available? 1, 2, yeah, 1, 2, 3, 4, 5, 6, and 7. I want even number, right? So let me fix this position with 2. I am fixing this, so which is one way. Let me fix this value with 4. This is also one way. This is with 6. This is also what? One way. Okay, when this is one way and there is another condition which is more than 3000, no, so you should concentrate on this value. So this is fixed, so I can fix this 3, 4, 5, 6, 7. How many ways? 5 ways. So two numbers are fixed. Okay, two numbers are fixed. Okay, guys, this is number 2. So I can say, so wait a minute, no confusion. So let me write like this. So this is 5 ways. What are the numbers available here? Let me put it in the bracket. 3, 4, 5, 6, and 7. I'm breaking the conditions. So this is what? 4 ways. Not 4 ways. Wait a minute. That's I know you should have quick response it. Okay. Out of 7 numbers, 2 is fixed. Okay. Any of the 3, 4 is fixed. So how many numbers are available? 1, 2, 3, 4, 5 numbers. So I can say this is 5 ways. So this is 4 ways. Okay. So I can say this is 100 ways total, because 5 5 is a 25, 25 into 4 what? 100. But whenever you come across here, look at here 4. So but I can fix this with what? 3, 5, 6, 7 only. That means I can fix this with what? 4 ways only. Okay, 4 ways. So out of 2 numbers is fixed. So this is how many ways? Again I'm sorry. So let me write clearly. So 3, 5, 6, and 7. So I can say 4 ways. I can say this is what? 2 numbers are fixed, 5 ways. This is what again? 4 ways. Okay, 5 fours are, okay, 5 fours are 20, 20 into 4. Okay, 20 into 4 is what? 80. Yeah. 20 into 4 is going to be what, guys? 80. Yes or no? Are you getting my point? Okay, so 20 into 4 is what? 80. Correct? Yeah. Here also this number is 4 ways. What are they? 3 and 5, 7, 4. So this is 5 ways, this is again 4 ways. 5 fours are 20, 20 into 4, okay, 80 ways. So total you can say 180 plus 80, okay, 180 plus 80, so that will give you total 260 ways, okay, total 260 ways. That's how you can end your answer. Total 260 ways you can get your answer. Okay, so the first two questions are pretty easy. Okay, so the first two questions are pretty easy, but these two questions are somewhat different. So be clear while arranging the digits. Okay, be clear when you're arranging the digits. So what we have seen so far, so we have seen the two rules, which are end rule and R rule. Okay, which are end rule and R rule. So after knowing rule of end and rule of R, okay, so what we have seen again, so how the rule of end and rule of R will work. Okay, so after knowing how the rule of R and will work, so R means what? Addition. End means what? It's a multiplication. Okay, it's a multiplication. Okay, so once you know that, the job is going to be very easy. Okay, the job is going to be very easy, guys. So this is how you can. So what we have seen, so we have seen only permutation, so we have not yet entered into combination. So permutation means arrangement, and order and position is important. So NPR means what? N factorial by n minus r factorial. We have seen how to calculate NPR. Okay, so this is how end rule and R rule will come into the picture. Okay, so we'll talk about in the next class the combinations. Okay, so this we have seen some problems regarding this particular thing. Okay, okay, so that's all for today, guys. Thanks a lot for being in my session. Have a great day. Okay, thanks a lot.